Assalamualaikum. I am representative from Group 2 and our members are Abdul Muiz bin Danial bin ISMAIL, Muhammad KHAIRUL bin MAZLAN, and Muhammad Danial bin RIZAL. Now, our group will present about topic related rates and apply maximum and minimum numbers. Now, I will continue to topic related rates of change. Introduction of topic. What is related rates? Related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. There are a few steps for solving related rates questions. Number 1. Draw the diagram and label dimensions. All the questions regarding related rates involve geometry or shape. Number 2. Extract the information and find the formula that relates to the questions. When we read the whole questions, they will provide you with important information. So, what we need to do is we need to extract the information from the questions and we need to make sure what formula should we use that relate to the questions. Number 3. Differentiate the formula using implicit differentiation with respect of time. Number 4. Solve the differentiation and find the rate of change stated.
Assalamualaikum and hello. My name is Abdul Muiz bin and I will explain about question 1. Sand is falling into a conical pile so that the radius of the pile is always equal to half of its height. If the sand is falling at the rate of 10 cm³ per second, how fast is the height of the pile increasing when the pile is 5 cm deep? Now we need to find the dH over dt. From the question, we know that the shape is a cone, so here is the formula. To find volume of the cone, it's 1/3 times pi times radius squared times height. So dV over dt equals to dV over dH times dH over dt. dV over dt is equals to bracket 1/3 from the formula times pi times radius squared. We leave out height because we're not here to find the volume, but dH over dt, and times it with dH over dt. Next, we fill in the radius, which is 2.5. After that, it is given that dV over dt is 10, and we get 6.5450 from solving 1/3 times pi times 2.5 squared, and times it with dH over dt. Finally, move dH over dt to the left side and divide 10 with 6.5450, and you are left with 1.5279 cm³ per second, which is the final answer.
Assalamualaikum. My name is Daniel. Now, I will continue for question 2 in the topic related rates. Question 2. The radius of a spherical balloon increases at the rate of 2.5 cm. Given that its radius is 7.5 cm, find the rate of change of the volume, the surface area. Give your answer in terms of pi. So, for this question, we need to solve and find the rate of change for the volume and surface area. As we know, first step that we need to do before solve the problem, we need to draw the diagram and label dimensions to gain a clear understanding of the question. Secondly, we need to extract the information and find the formula that relates to the question. The information that we can extract from the question is the radius of a spherical balloon increases at the rate of 2.5 cm. It means dr over dt equals 2.5 cm for the rate of change for the radius, and radius equals 7.5 cm. We need to find dV over dt. to find the rate of change of the volume. The formula that we use for this question is 4 pi r cubed over 3. Now, for the step number 3, we need to differentiate the formula using implicit differentiation. So, it will be dv over dt equal 4 pi r square dr over dt. Next, we need to substitute the information and solve the equation. dv over dt equal 4 pi r square, we need to substitute with 7.5, and dr over dt we need to substitute with 2.5. The final answer is 562.55 centimeter cube per second. We need to let the answer in the terms of time because the question needs us to give the answer in that terms. Now, we move to question B. In the question, we need to find the rate of change for the surface area. Now, we will extract the information given. dr over dt equals 2.5 cm, radius equals 7.5 cm. We need to find ds over dt, that means rate of change for the surface area. The formula that we use for this question is 4 pi r square. Same step from the previous question, we need to apply implicit differentiation into the surface area formula, and we will get ds over dt equal 8 pi r dr over dt. Now, we will substitute the information and solve the equation. ds over dt equal 8 pi, we need to substitute r with 7.5 and dr over dt with 2.5. And we will calculate the answer. The final answer is 150 pi centimeter square per second. That's all from me. Thank you.
Therefore, in conclusion, related rates comes in handy when we have two related quantities and one of their rates of change is much harder to find than the other one. Other than that, we would also need to know the formula of the shape that is given to us in order to find the d variable over dt.
Applied maximum and minimum problems. The terms maxima and minima refer to extreme values of a function. That is the maximum and minimum values that function attains. Maximum means upper bound or largest possible quantity. The absolute maximum of a function is the largest number contained in the range of the function. Minimum means lower bound and least possible quantity. The absolute minimum of a function is the smallest number in its range. Question 3. A rectangular flower garden with an area of 30 meter square is surrounded by a grass border 1 meter wide on two sides and 2 meter wide on the other two sides. What dimensions of the garden minimize the combined area of the garden and borders? Okay, this is the answer for the question 3. First thing that I do is I draw the diagram and label all the dimension and information that I get from the questions. So this is the information, one of the information that the question gives, and it's the area of the garden equals to 30 meter square. And this is the combined area formula, the combined area of the flower garden with the borders. And this is the formula that we are going to use to solve these questions. So it is W plus 4 is this W plus with 2 meter with 2 meter border wide, and the length, the L plus 2 is this length plus width 2 meter wide, the borders. Okay, so we need to just have one variable to use this formula. So I try to change the L with only have the variable W. So with this information, I try to move the W to the left side, so it would be 30 over W equals to L. So we use this instead, substitute it into this formula. So we will have only one variable, the W. So I simplify the formula and I get 2W plus 120 over W plus 38. So the next step is to find the first derivative. So I differentiate this equation. So I get 2 minus 120 W to the power of negative 2. So after that, we need to substitute the dc over dw to 0, so that we can get the value of W. So I move this negative 120 to the left side and use this form and move the W squared to the right side and simplify it. 120 divided by 2 and get 60. After that, I need to exclude the square, so I get this value equals to W. So after that, I need to find the second derivative. So I differentiate again this equation and I get 240 W to the power of negative 3. So we already get the value of W, so I just substitute this value to this variable and I use the calculator to simplify it, and I get the value of 0.52. And I try to check if the value is greater than 0, and yes, so that it is the minimum. So after that, the question asks about what are the dimensions. So we already get the value of W equals to this value, but we are not yet get the value of L. So we know that L equals to 30 over W. So I just substitute the value of W, this one, into this formula, and I simplify it using the calculator, and I get this value, length. This value equals to length.
Assalamualaikum, my name is RIZAL. I am from group 2. I would like to present question number 4. An open top container is full of water. The container is made up of hemispherical ball of radius r attached to the bottom of the cylinder with radius r and height h. If the surface area of the container is 288 pi centimeter power of 2, show that its volume is V equal to 144 pi r minus 1 divided by 3 pi r power of 3, and B, hence we need to determine R so that the volume is maximum. First off, by the description, we can get the container was combination of cylinder and hemispherical ball. To find the surface, now we would like to find the height. We search the height by taking by the volume of surface. 288 pi equivalent of the the both surface of the cylinder and the hemisphere, which is 2 pi r h plus 2 pi r power of 2. And then we put out 2 pi, pull the value of 2 pi out from both of these, and then we bring 2 pi under so that we can divide pi minus divided by pi minus, then 288 divided by 2, then we get 144 equivalent as RH plus R power of 2. And then by arranging it, we can get that H, the height, is 144 minus R power of 2 divided by R. And then we go to the volume. The formula of the volume was the combination of the hemispherical and the cylinder. Volume equal to pi r power of 2h, the volume of the cylinder, plus 2 divided of 3 pi r power of 3, the volume of the hemispherical. We add the value of the h into the to the height of the cylinder, and then we multiply inside and into the 144 and the r power of 2, then we get volume 144 pi r minus pi r power of 3 plus 2 divided by 3 pi r power of 3. Then to finalize it, since this means 1, the negative 1 pi r power of 3 must plus 2 power of 2 divided by 3 pi r power of 3, and then we get ourselves negative. That's how we get negative 1 divided by 3 pi r power of 3, which is the volume, or the entire volume was 144 pi r minus 1 divided by 3 pi r power of 3. Hence, it was proved that the volume is, as we want to get, 144 pi r minus 1 power of 3. And then we're going to determine R so that the volume is maximum. Firstly, we differentiate the volume, the previous volume, and then we get the result to be V prime is 144 pi minus pi r power of 2, and then we calculate the critical points, in which 144 pi minus pi r power of 2 equal to 0, and then we calculate, and then we get r equivalent to positive or negative 12. But since the value of r can't be negative, therefore the r will be positive 12, and we get ourselves r12. Then we differentiate the volume again, and then differentiate the differentiate the value from here. We get V prime equivalent to negative 2 pi r. Then we put the value of r into, then we get negative 2 pi in KH12. Then we get V prime less than 0. Using the second derivative test, there will be a maximum at r equal to 12. Therefore, r equal to 12 will give the maximum volume. Thank you.
Many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such function will determine the domain from which you must work. The function together with its domain will suggest which technique is appropriate to use in determining a maximum or minimum value, like the first derivative test or the second derivative test.